Welcome to General Structures 2 and Lateral Forces, Lesson 2 quiz, question number 7. And it says a two-way truss system is kind of blank, and then you have A, B, C, and D. And a two-way, remember a one-way truss system is looking at it above, you'll have a girder, it can be a truss as well, but then you'll have these these like joist trusses, like every 6 foot or something. Once again, go into a Walmart or a Sam's Club or a Target or Costco, one of those larger buildings, and you'll see that that's the way they look, and you kind of have a slightly isometric view. That's terrible, but you get the point. So that's the way they are. The way you look at it is you'll say, okay, this is distributed area for this truss. It's right here for that joist. And we're going to switch colors, and the distributed area for the truss that's in the middle is right here, and then those transfer to loads. You'll get let's go to green. So for this half right here, it'll see a point load right there at that point, and then let's change colors again. This half, that distributed area will go right there, and that's how it is. So this joist will end up seeing a point right here, a point right here, a point right here, and so on and so forth. And this do just the opposite. You'll see a point, and that's a one-way system. A two-way system is similar. We've went over. I'm not going to beat this into the ground, but a two-way system looks more. Think of the waffle slab where. Instead, if you put something right, well, for instance, if you put something right here, you will automatically assume, oh, it's going to go to that joist, and therefore that load's you're gonna look at it like a simple span. And if you have so much of that, and there's ways you can figure that out. We'll do a shear moment diagram, and you can get your reaction right there. And then you'll get a smaller reaction right there since it's closer to this end. It'll be slightly smaller. This is the middle. So a little over half of that that load will go to this joint, and the other half will go to this. And that's how you distribute your loads generally. Now, in a two-way truss, and this isn't entirely true because you want to. I mean, how much is that slab going to distribute that load as well? So in a perfect system, that's what I'm trying to explain here. If you didn't have a slab on top, that's how you would look at it. Now in a two-way system, it looks more like a checkerboard, I guess. And I'm not going to draw it intricate because it looks like that. So let's say here's a joist, or I guess you'd call them a beam or a girder. And if you put a load right here, theoretically, a little bit will go this way, a little bit go that way, a little bit will go that way, and a little bit will go that way. More will go this way and this way. So it's a little bit more difficult to analyze in my book, but because the one way is very simple for me. But that's just the basics of the two-way versus the one-way. So let's look at these answers and see which one would be incorrect or correct. And we're looking for the correct answer. And A says, is efficient when the spans in both directions are about equal. And that sounds good. And I've explained before, this 2-to-1 ratio is what I've used in the past. Is if it's over 2-to-1, or even close to 2-to-1, I would say it's less efficient. But if you have a square, like this would be a good one. Because these sides are about equal. If this is a 1, a 1, a 1, a 1, those are ratios, of course. So that's 1-to-1. But if you have something that's longer, like so, a one-way system would be more appropriate. All right, so let's double check and see if these other answers are worse or the incorrect answer. So let's go to B. Is deeper than a comparable one-way slab, and I would say that's incorrect because usually since you have more, it will typically be more shallow. C does not lend itself to cantilever action, and that's incorrect. You can actually use these for cantilever stuff, which we're not going to get into right now, but I guess it might be I haven't looked, it might be in the study guide. I'd take a look. And in D, it is simpler to design and build than one-way system. And I will say that that is definitely incorrect as well. This one-way system is very easy to build and design. As I said earlier, what you'll typically do is you'll just take well, these are all, you just get your loads, and then you distribute your load. You go, your span is the same thing as a distributed. Say they're 6 foot on center, you have a distributed area of 6 foot. You take that times your length, which this is going to be L. Let's say that's, I don't know, 40 foot. So you take your load times those two. Well, actually, you'll just take your load, which was going to be, let's say it's 50 PSF, I'm making things up, times 6 foot, so you'll have 300 pounds per linear foot on top of this girder, so it'll look like that. And then if you're looking for bending or whatnot, you can do so. But if you want to go into the tables like we've done on these previous questions, is you'll probably need to multiply and see what your load is. So you'll take 30 times 4, which is what? 1,200 pounds. And it kind of depends what you're looking at. If you're looking at only this right here, you would look at half, and that would be your half of that is what's coming into here at your reaction. But we've done that before. Go back and look at some of the older lessons, and you can figure out how to do that. And review the study guide. It gives a good overview of how to do that as well. All right, I will see you on question number 8.